Hello, everyone. Welcome to this webinar. Today, we're going to talk about FCC compliance in 6 gigahertz. We have here David from NetPoint. Welcome, David.
Thank
Uh,
you.
Please feel free to drop your questions in the chat. We will answer it at the end of the session. Mm, David, you can start now.
Thank you. Thank you, Juliana. Hi everyone again. So it's my pleasure to stay with you here. I appreciate your time to hear this live webinar. This will be a very fascinating webinar because we're going to talk about the 6 gigahertz complaints from the FCC. And the most important, where we can pair it with that rules with NetPoint antennas. So this live webinar is sponsored by Flytec Computers. And so my name is David Alvarez. So today we're going to talk about, or the agenda for today, it's going to be the 6 gigahertz market context, the FCC regulatory frameworks, NetPoint solutions, 6 gigahertz products, and the pre-deployment requirements, and question and answer session. Okay, so we're going to start with the 6 gigahertz market context. Why 6 gigahertz matters, the congestion and limited stability, growing demand for high capacity wireless link. As data consumption rise, that driven by streaming, broadcast, cloud service, IoT, and the 5G service provider, and the most important, the enterprise require more reliable and high throughput wireless connection. The 6 gigahertz that supports multi-gigabit wireless backhaul solutions and 5G wireless access, making it ideal for rural or urban connectivity expansion. What means with that? We are we are in a new age where the high throughputs, the high quality, and the demand of the internet connections, it's still growing every day. And the most important, we need to make more strong links for end users and for the West around the world, but most specific in the United States. Right now, the legacy on the only sense bands in around the world, 2.4 gigahertz and the 5 gigahertz at satellite. To do widely press, they use the Wi-Fi IoT devices and various wireless wireless system. Congestion leads to interference that reduce the performance and the limited scalability in these bands. The most the most particular in the 6 gigahertz, and the principal highlights, it's the wider channels, because with a wider channel we can achieve a better throughput. We can get, for example, excellent low latency, and the most important, we are ready for use that technology up to the 160 megahertz channel, and more in some regions. For example, enabling faster data rates and low latency. So we think that 6 gigahertz it's ideal for the high performance applications, right? Because less interference compared to the legacy bands or other bands that for example, 5 gigahertz, 3 gigahertz. Now with the CBRS is still working, and we have a new opportunity for work together on and multi-link operations bands, and that's new opening and regulated with better coordination. Because if we make memory, about the use of the 5 gigahertz and the United States, the regulations, it was a chaotic relation because everyone's used the 5 gigahertz for war right now. But what happened? All the types of deploying change. Right now we are using, for example, fiber to the home combined with the wireless, and the FCC right now take the control with a better way to get a better coordination, and the 6 gigahertz going to provide support emerging technologies for point-to-point multi-point links right now. Why we can do with that? Well, we can work with the specific bands. We work to achieve a better throughput, and the most important, we can check the interference in your area where you're going to begin to deploy. Why? Because the 6 gigahertz band, it span from 5.9 to 7.2 gigahertz. It's a total of 1,200 megahertz of the band. And the most important, we can provide better internet and make more reliable and achieve scalability in all the deployment with the 6 gigahertz. The FCC regulatory framework, or DITS, is to divide in the subbands. Now, has each subband it's a different rules. For example, the low powers and indoor deployment and outdoor, and the use and device types, with the most important of this, with no automatic frequency coordination. Well, we need the system, the FC system, or well, the automatic frequency coordination as required in all the products on the 6 gigahertz right now. Design even on the Wi-Fi 6 gigahertz, on the Wi-Fi 6E, and the Wi-Fi 7 routers, and consumer devices. So what we do when the automatic frequency coordination of the, well, with the system, with the AFC system. Well, the automatic frequency coordination is a system designed to provide interference between all licensing bands like Wi-Fi, as I say, or wireless backhaul radio, and licensed uncoupled service separation on the 6 gigahertz bands. With this, we can make such as possible microwave links, satellite and ground stations, and get utility Diability networks. In this set, the automatic spectrum is an automatic spectrum management system that dynamically alters the frequencies and power level based on the concurrent spectrum used in a specific location. In, in the most simple words, the FCC coordinate in which band you are going to begin a work. For example, if you try to make a link in 6 gigahertz in Fort Lauderdale in Florida, well, the FCC with the AFC system is going to check which frequencies is used in that place, in that area, and it's going to give you what going to be the power that you have available there, and the most important, you're going to have your personal frequencies for works in that areas, or maybe in that locations, or for specific customers that you want to deploy. The most important is that how the FCC works in the simplified process. As I say, we're going to start with the device initiation and standard power in the 6 gigahertz device, the radio or the access point. starts up in the request frequency access. For example, if you're going to work, for example, in 6.4 gigahertz, you going to check the requests and the frequencies, and it's very important. Your gear, you always going to be determined by the precise geographic location with GPS or your manual or your configuration. That's mean with the use of the GPS on your radio, for example, you are using an antenna with a stellar radio, okay, your GPS going to help to determine the area where you're going to begin for work. And the most important, the compliance on the FCC have the principal focus in don't use all the power of the radios and approve the power of the antennas. Why we can do that? The query of the FCC system is the device sends a request to the FCC certified FC system, including the location and the device characteristics, for example, the power, the levels, the antenna height, etc. And with that, you have the channel assessment to the FC system to check for nearby incurvers user and increase the FISET microwave system and return the list and return to you with a list available to channels allowed for powers level, and that device can safely for use. With that, you don't have interference for other users and you can approve all the channel width. And the most important, you can get a better throughput on the for the end user, or maybe to make the distribution of the internet more easily. And the most important, you're going to have one link reliable in all the time. After all of this, the operation authorization, the device configures the radio to operate only with the ISINET channels and parameters. For example, if we go to work directly with gears like Mimosa's C6X, or maybe with the Cambium APMP 4600C, with the GPS, you're going to notify to the FCC in the areas where you going to begin for work, with most specific in bulk radios, or maybe if you're going to deploy in areas where nobody is deploying right now in the 6 gigahertz, maybe you can achieve all the bands completely with I'm sorry, without the authorization for all the channel bands. But we have one real very important we can have to make the complaint. We need to one principal rule, mandatory rule on the 6 gigahertz. That's the power. The power they can works in a specific in the 6 gigahertz band. It's the power from 6 dBA, and that power that will be combined with the gain on the antenna. And the most important, we need to improve. If you want to improve backhaul links or CPL links for the end user, okay, you need to consider which going to be the distance, and one thing very important, what is the throughput you can achieve, right? The device it's configured with the power of the radio, and the gain and antenna. And then all we have all the sorry, we have all the areas for work very closely, and we have other very important thing in this area. We are ready to still deploy in more places around all the certification, all the assigned channels parameters on the FCC. For example, how NetPoint helps in the 6 GHz regulatory and deployment context. Well, the principal area in these cases in the highlights on the NetPoint is more specific NetPoint's products and service align with our support and regulatory frameworks and deploying the requirements in the 6 gigahertz band. Why? Because we offering antennas that covers the frequencies from 5.9 to 7.2 gigahertz band, and NetPoint along the deployment to exploit the 6 gigahertz range, right? We have fully the 6 gigahertz band for words, and whatever Delta radio you said must be certified with the FCC. And the most important, all the radios in the United States right now have the standard power and the outdoor uses for the FCC regular compliance is required. That with that we can choose in use, for example, in areas where you had, for example, links from 7 miles, you can deploy NetPoint together with any brands in the market with the FCC, with the AFC complaints that you and that we are very and we are working to deploy antennas with high gain and high stability for words in all the 6 gigahertz band. For example, the manufacturer on the high gain and parabolic antenna for the point-to-point links and CPE links. Their products line includes model MP6, MPX, MP Gen 2, MP64, MP66, designed to cover the frequency, for example, in any cases, for example, on the 5 gigahertz from 4.9 to 6.4 gigahertz. But we have other family lines on the net point, for example, for the standard performance in the 5.9 to 7.2 gigahertz range. In the cases where you don't have interference, or maybe you have areas with an insignificant requirements from your customer, but do you need, for example, high performance in all your deployments with the 6 gigahertz? We have right now the models MP at 6. The model MP at 6 of NetPoint covers the same frequencies from 5.9 to 7.2 gigahertz, but the most important, the antennas have all the been in the focus to achieve great a great gain and stability. And what other things offers with NetPoint? So we offers directional precision, high front to back installation, and good BSWR to capable for long distance over the 10 miles or maybe 50 miles, or do you prefer from maybe 3 kilometers up to 150 kilometers, depending on the model and the antenna. The principal highlight of the NetPoint products works directly with the FCC compliance. It's reduce the noise interference, and the most important, it's work directly for works for the point-to-point links deployment, or you can achieve the user antenna for CPE connections. The most important, it's a broad compatibility and flexibility with other type of gears. For example, gears like Cami networks, Mosen networks, MicroTik, Ubiquiti, Radwin. even asteroids and other more. We have support on your deployment, and the most important, you have local stuff in the states and warranty. And without these antennas, covers the frequencies from 6 and 7 gigahertz band. That products all the network products it's built in Mexico, and design and the design and the and it's manufactured in Mexico. Sorry, we don't have tariffs right now, and that's very important because you need to get a better return on the investment. With NetPoint, you can achieve it, and you have a better quality and get a better results that other manufacturers around the world. But right now it's available in the United States. For example, the family on the net point, we had a very specific family. For example, in the 6 gigahertz models, you can use in the for short distance links. We have products like MP6 TP2 foot. With that antenna, you can cover the frequency range up to 30 kilometers. In the most important in that, you have 37 dBi of gain in the antenna, with a very particular in a very particular very with low profile 2 foot antennas. And you have the dual slant for use at 40 degrees in the antenna, and you can deploy it, for example, with the cambion gears, or maybe with ubiquity of that. You If you prefer Mimosa, you can do it. It's very flexible. That's the principal reason why NetPoint is very successful with the ISPs around the world. And for example, if you need more gain in that cases, for example, because you have a lot of power in the area, or maybe you have channels very close to the 7 gigahertz. So I have a good news for you. All the antennas on the net point working from the frequencies from 5.9 to 7.2 gigahertz band have the gain very focused in. You can get the better result in the beginning of the band and the final frequencies of the band. Well, where you with this you can achieve a very good signal. This is very important because right now I see a few a few links around the United States with other gears together and other type of antennas, and the signal is around from 72 dBn. Well, with NetPoint, you can achieve 16.5, or maybe you can achieve 16. And that's incredible. I think that's pretty sweet because with things with that, you can improve more your links, and most important, you can achieve a better throughput. For example, in these cases, we recommend to use the 3 foot antennas, the principal model MP6 DP3 foot with 32 dBi of gain, and 3 foot antenna with dual slant. You can achieve a good signal, as I said a few moments ago. And the most important, you can use that antenna for long distance. If, for example, maybe 12 miles, or maybe 15 miles. Why not? And for example, if you need long distance link, for example, you can achieve with the 6 gigahertz models with the super deep antennas of NetPoint with radome. And the most important, that antennas, the principal focus is inside on the beam, and the beam in these antennas is very closely, if 2 degrees, 1.8 degrade, with the same frequency range, but with the size from 4 foot or 6 foot. You can use, for example, The 36 dBi antenna on NetPoint. It's a model MP6 SDP 4 foot. With that antenna, you can use a long distance link with almost in a distance up from 100 kilometers or maybe 65 miles, or you can choose to use the other model, the 6 fold antennas. That antenna is used more for licensed band in the 6 gigahertz antenna, in the 6 gigahertz, sorry, deployment, with gears and with very specific frequencies. For example, 6,800 megahertz or maybe 7,000 megahertz. So we can choose to use, for example, the modem in 6 foot antenna with 4 dBi, and you're going to see the size of that antenna in the reasons that you why to use NetPoint in these cases. All the antennas on NetPoint having the bots include the jumpers or the coaxial cables, and with that you have all the integration together because all the gears connectorized in the needs jumpers, for example, to make this more easily for worse for the ISPs or any deployer around the world. We have in the antennas the connector and female, right? Because the and female is more strong, is more reliable, and the most important, you can find very easily one jumper with connector and female to SMA metal. So, and this is great. This is to make the antenna more fast to deploy. One thing very important: all the antennas, it's very lightweight, and this is very grateful for all the tower climbers that's work. For example, if you don't have all the facilities for deploy the 6 gigahertz antennas in even in 4 foot or 6 foot, and it's in a places very far, you can make the movement antennas very easily. And the most important, the deployment time is very fast, and we thinking in made the things easy for you, right? Right now, we had other challenge in the 6 gigahertz antennas because we're still waiting for new gears of radio gears deployments. Sorry, we are expecting for new radios manufacturer to introduce the radios with the AFC with the AFC regulatory compliance from the FCC to get a better results, and the most important, give scalability to use for the users. For example, if you are deploying Cambi networks, you can change to Mimosa, or maybe one day tomorrow you can prefer to use the radios like Wavy Milos 5 and 6 from Ubiquity. Another very important things you can improve to use, for example, with Air Fiber 5 HD from Ubiquity or other ones stuff like that. The most important is this: we are ready for work with any radio on the market. But if you are considering for works directly in the United States, you need to deploy NetPoint with one radio with the AFC system, right? So why NetPoint might be the best choice? Well, in resume, the high gains in antenna and the more stable links, important for butthole links over over kilometers, better signal strength, and less susceptibility to interference or noise. The wide frequency covers mean flexibility to especially to regulatory re- regimens and comparing and competitive spectrum may be shit. Other very important things to make the integration very easily with operators can make radio they're ready to prefer to have to prefer the dual polarization held to capacity and reduce the polarization much losses. This is very important because one thing in any manufacturer in antennas, it's the the loss between the change and the BSW are in the antennas. If you have a high value of a high value BSW R in antenna, well, your antenna not going to work very well. But the FCC, in this case, with the FCC compliance, with the with the net point and the radius of Mimosa, you can get a better results. For example, with Mimosa, with the Cambion, with Ubiquity, with NetPoint, you can improve any links if you want to deploy. For example, other one thing with NetPoint is the difference on the size and antennas. Have you if you see here in the picture, we I am here with one antenna from 2 foot, and between that 2 foot antenna we have a 6 foot antenna, and with that we have different sizes where we can choose between the gain, the bandwidth, and different and you can consider it to deploy different types of different type of links around your authorizations or channels with the FCC. The most important in this case is you can change the game only with choosing a good antenna size for your deployment. And one thing more, that antennas work in the most harshest environments in the around the world. For example, if you have if you are, for example, in Montana or maybe Wyoming, where the wind is very strong and the snow is very, it's very hard. The stars snow where, well, the antenna has, for example, the radon cover, have the stiff arm, and we can work in the specific areas. For example, the laminin and the antennas make the antenna more lightweight, like has a, and one thing very important, the focus on the antenna, it's always working with the same gain in all the band, right? Why we can achieve that? We achieve that working in these scenarios where the interference is very high, and we improve the focal point on the antenna, where the ISPs they can get better results and make different any link. Why? Because we understand you need to make this more reliable, and we can work to make reliable any link that you want to deploy inside of the United States or any place around the world. Well, where's other highlight on the NetPoint antennas? Well, in resume, we help to reduce interference. That is very important to reduce density of the usage spectrum or nervy to other links, because with the focus in the antenna, we can achieve a better signal potential, and the most important, you going to get a better results with NetPoint together with any radius, and you can improve the efficiency, or any brand the radius that you want to deploy, and the most important, with the energy, with the better signal quality, and the better reflection and multi-pack uses. With this, I don't know, do you anyone have questions and answers? So we are ready to receive your question and answers. So you don't forget, you can write your answers here in the chat. So
David, I think we have a question.
okay.
If the devices are in an isolated location, are they required to contact an AVC system? How does that work?
Okay, for the deployment, yeah, you need to make the contact with the APC system, but it's very important that you can check with in the gear, inside of the gear, the APC systems is going to begin for work. For example, I see this is very particular in the Tarana products, and if I remember, in the Cambium products, you can deploy, for example, the the antenna in any location. For example, we're going to think I'm going to think deploy on Kentucky, right? But in Lexington, and you install the antenna, and then you install the radio together, and you begin for make the to make the scan on the frequencies, right? It's very important that you can have deployed with the radio, the GPS. Okay, with that, you're going to have all the channels and the frequencies available on the power that you can deploy. You don't need to make any contact to the FCC, only with your license that you have to deploy the antenna, and then you have all the spectre free for work. But it's very important that you want to get a better information about that. You can write to me directly, and we can canalize to you with one specialist of this and in this area. For example, if you need a license or anything.
Okay, I think we don't have more questions. So thank you, David, for this webinar, and thank you all for joining us today. Please stay tuned
Yeah,
for
yeah.
upcoming sessions.
Yeah, we have, for example, we are very excited to see you the next month for all the weeks in the United States. We're going to stay Wispapalooza this year. This is very important. You can visit NetPoint at the booth 301, and we have so many things to present to the market. For example, we're going to present the new antennas for license band. We're going to present the new products for high sorry for high performance in 6 gigahertz. And we're going to present two new products in the line on the 6 gigahertz for works in all the wide band in working in the frequencies range from 4.9 up to, very important, up to 7.2 gigahertz band. We're going to make this more easily, and the most important, we're going to help to your economy. So guys, you can contact us. This is my email here, david.alvarez @antennas.com.x, or my phone number. I have e-message available. So if you use WhatsApp or any other kind of service, we are ready to help you. Don't worry.
Thank you for joining us, and thank you everybody for joining us. join this webinar today. Please stay tuned for upcoming sessions and have a great day.
Thank you. Appreciate your time. Have a good one for everyone.
Thank you. Bye.